Alrighty, so if you try these problems, this will be a quick recap. I'm not going to show the actual graphs themselves, just the values on the table so you don't need me to check a graph for you. Similarly, you can always use Desmos to say how you're doing. This one is certainly in vertex form. A value is 1, H value is 3, K value is 1. So axis symmetry is x equals 3, and your vertex is 3, comma 1. Make it the table. I put 3, 1 right smack dab in the middle. And again, you can do whatever numbers you want, but I'm thinking it might be nice just to count and go in order. So can hopefully 2 and 4 give us the same result because they should have mirror images. Likewise, 1 and 5 should get the same result, which should be mirror images. So if I plug 1 into the equation, 1 minus 3 is -2. -2 squared is 4. 4 plus 1 is 5. If I plug into the equation, 2 minus 3 is -1. -1 squared is 1. 1 plus 1 is 2. That should mean, if we do things correctly, 4 is going to also get us a 2, and 5 should get us 5. 4 minus 3 is 1. 1 squared is 1. 1 plus 1 is 2. That's a good sign. And then 5 minus 3 is 2. 2 squared is 4. 4 plus 1 is 5. And there you have it. That should be enough to make you have a nice, smooth view as far as your graph is concerned. Second problem. A is -2, H is 1, and K is not there. So K is 0. Axis symmetry is going to be 1. Vertex is 1, 0. But again, it's being -2. Better be opening down or being upside down U, so to speak. Again, I put my vertex right in the middle. And again, the two numbers before and two numbers after just seem to make the most sense to me. But again, you can do whatever you want. It's really up to you. If you throw in 0, 0 minus 1 is -1. -1 squared is 1. 1 times -2 is -2. Keep doing that. You throw in -1. -1 minus 1 is -2. -2 squared is 4. 4 times -2 is -8. If things correctly, we better get -2 and -8 here. 2 minus 1 is 1. 1 squared is 1. 1 times -2 is -2. That's comforting. 3 minus 1 is 2. 2 squared is 4. 4 times -2 is indeed -8. And lo and behold, can we have kind of mirror images, which is the whole idea of what the axis symmetry does for you. Third one. A value is 1, H is -2 in this case, and K is -4. Again, remember H in the model has a minus there, so if you saw a plus, you'd have to process it accordingly. Can I put my vertex right smack in the middle of my table, and I went two numbers before and two numbers after. Plugging in 0, 0 plus 2 is 2, 2 squared is 4, 4 minus 4 is 0. -1 plus 2 is 1, 1 squared is 1, 1 minus 4 is -3. Hopefully -3 gets me -3 as well, and -4 should get us 0. -3 plus 2 is -1. -1 squared is 1. 1 minus 4 is indeed -3. That's comforting. Of course, -4 plus 2 is -2. -2 squared is 4. 4 minus 4 is 0. Also feeling pretty good about that. Last one. A value is 1/2. H is 1. K is 1. And the axis symmetry is x equals 1. Vertex is 1, comma 1. And I put that right in the middle of the table, but I did not count order here. And my thinking is, I say I have a half here. So I want to pick numbers. So when I subtract 1 and I square it, I get an even number because taking half of an even number leaves me with whole numbers. And you can do whatever you'd like, but you might want to think about how can I make numbers more friendly or easier to work with. So you sort of kind of gone in order, but chances are if you did a subtract 1 and squared it, you got an odd number, and half of odd number results in decimals or fractions, which is fine. But if you're picking numbers, why not pick things to your advantage? So that's why I jumped around to make things still be jumps of 2, so it's still continual, but it'll make my values nice and clean. -3 minus 1 is -4. -4 squared is 16. Half of 16 is 8. 8 plus 1 is 9. -1 minus 1 is -2. -2 squared is 4. Half of 4 is 2. 2 plus 1 is 3. Again, just like before, that should mean that we should be getting 3 and 9 here to mirror that. 3 minus 1 is 2. 2 squared is 4. Half of 4 is 2. 2 plus 1 is 3. That makes me feel pretty good. And lastly, 5 minus 1 is 4. 4 squared is 16. Half of 16 is 8. 8 plus 1, you guessed it, is 9. Hope that worked out for you.